Hello everyone, Mr. Minnick's my name, math is my game. Today, on this 22nd of March, I'm joined by my first period Algebra II class. Just got done with the ACT, just got done with a Monday quiz. So here we are, we're engrossed in this Chapter 8. Chapter 8, big picture. I think sometimes we don't take time to think big picture. But the big picture is Chapter 8 is all about working with polynomials, in case you didn't know, which is what we did in Chapter 5, which is why we went from Chapter 5, and then we took a break to the unit circle, and now we're back in Chapter 8 because it's all polynomials. That's all it is. So you can see the title. It's Chapter 8, Section 6, solve rational equations. In the last two sections, we talked about simplifying rational expressions. We talked about multiplying and dividing rational expressions. And we talked about adding and subtracting rational expressions. So you might notice the key vocabulary, cross-multiplying, should give you a kind of a hint as to one thing we're going to have to do. And then there's that other word. It's kind of a big word, that E word. What's that? Extraneous solutions. We've encountered those a few times, I think, this year. So we'll see what that's all about when we get to it. So before we dive into this, I'd like to give a shout out to my second period class. I'd like to give a shout out to my sixth period class. And this time, the future Mr. Minnick does not get any shout outs. He doesn't deserve them for giving a Monday quiz. So here's an overview. Here's a roadmap of where we're going to be going with these examples. Early on, we're going to see something like this. There's going to be an x somewhere, obviously. There might be a 2x minus 5 here, and there might be a 2x minus 5 here, and there might be something like a 3 there. And you're going to have to solve that. Now, there are a couple things that nobody ever tells you about, bless you, about solving these kinds of equations. Oh, proportions. There's something about diagonals of proportions. If you're not aware of this fact, be aware of this fact. We're dealing with a proportion, and anytime you work with a proportion, what can happen is terms can move around along the diagonal of a proportion. So what I mean is if I were to copy this thing, which I guess I'm going to, go ahead and clone all this. I'll make it red just to contrast the color. So what I'm saying is anything can move along a diagonal. So if I wanted to do this, I could take this 2x minus 5 and slide it right up next to that 3. Everybody see what I got going on there? Okay. Now, if I did that, what's going to happen to the 2x minus 5s? Oh, they're going to cancel, like what happened when we looked at multiplying and dividing rational expressions. They're going to cancel because they're exactly the same factor. And we get x equals 3. So one little thing to take away from this is in a proportion, if we have the same denominators, you know what that means? They cancel, and we can disregard them, and we can simply set the numerators equal. So if we looked at this problem up here, what we could have done is just said, okay, this is irrelevant, x is 3, and that's it, we're done. I told you some of these things are going to be real simple, real straightforward. The same is true if the numerators are set equal for similar reasons. Everybody okay with that? So the numerators would cancel each other out if they're similar, and then you could just set the denominators equal. Do we need to see that, or do we have faith in that and we're good? Need to see it? All right. So maybe we're going to have something like this. X squared minus 8x plus 4 divided by x plus 6 equals x squared minus 8x plus 4 divided by 5. Okay. Again, because of the way things work, because because in a proportion things are allowed to move along a diagonal, what we could do is we could take this whole term and slide it down to here, x squared minus 8x plus 4, and so that would end up canceling with that. And what would kind of hold the place in the numerators would be 1s, and then we could invert both sides or flip both sides. So we'd have 1 over x plus 6 equals 1 over 5, and we could invert or flip each side over, and we'd have x plus 6 equals 5, and so x would equal what? -1. Okay? Or we merely could have just said, well, the numerators are identical, so guess what? The denominators are identical, and we could have just looked at that equation and solved it. What do you think? Nobody ever showed you that, did they? You're welcome. Kind of cool. There are a couple of exceptions to that. What if we had something like this? X minus 5 divided by x squared minus 25 is equal to, well, I messed that up. That's my bad. Let's make it x over x squared minus 25 equals 5 divided by x squared minus 25. Let's make it like that. So I've kind of suckered you into setting you up for the fall. Not the fall as in autumn, my favorite time of year when the leaves change and when you go on straw rides. Yeah, I said it, straw rides, not hay rides. You never go on hay rides, but that's another story. So anyhow, a lot of people would say, well, Mr. Minnick, based on what you just told me, the answer is going to be 5. Why isn't it going to be 5? Because it's a perfect square trinomial? Well, I don't think it's so much because of that. Who could tell me why 5 doesn't work? So we have x equals x plus 5 and x minus 5 equals 5 over x plus 5. So when you factor it, something happens? Well, those are still identical. So why doesn't 5 work? It just doesn't? So what's wrong with having 0? Somebody said, well, if we plug in a 5, we get 25 minus 25, which is 0. What's wrong with having a 0 in that? What can't equal 0? X can equal 0, but there's something, you're right, something can't equal 0. What do we got? Because 5 squared equals, well, 5 squared is going to equal 25, and there's something to that. There's something to that. Let's see what happens if we plug a 5 in. We'd have 5 divided by 25 minus 25 equals 5 divided by 25 minus 25. Well, that looks to be true. But that's 5 divided by 0 equals 5 divided by 0. What do we know about dividing by 0 in math? It's kind of like doing 170 in a school zone. What's wrong with doing 170 in a school zone? It's illegal. And in math, dividing by 0 is illegal, not advisable, not cool. The calculator could be your friend if we had them. We don't. You know, you can do this and solve. Type in the equation. Here we go. X divided by x squared minus 25. I said x squared minus 25. And we could set that equal to that fraction, 5, divided by x squared minus 25. Let's solve this thing for x. And the calculator knows what's up. The calculator knows that division by 0 is undefined. And because a while back, remember when we talked briefly about the restrictions in Chapter 8, Section 4? Because of those restrictions, we can't plug a 5 in. We can't plug in anything that would make the denominator equal to 0. What do you think? So there are some exceptions to the simplicity of problems such as these two that we started with. Everybody all right so far? Okay, so let's go ahead and look at some of these examples then that are in the books problems. So we've got 3 divided by x plus 1 set equal to 9 divided by 4x plus 5. And the key vocabulary includes cross multiplying. Now, in case you've forgotten, whenever you solve a proportion, that's how you do. That's how you solve a proportion. You cross multiply. It'd be nice. It'd be real nice if these numerators were the same, wouldn't it? Anybody feeling creative today? Anybody see a little trick that we could do to use that trick that I showed you a couple minutes ago? What do we think? Multiply what by 3? The 3 over x plus 1, multiply it by 3, you're close. I think you mean the right thing, but you didn't say it right. If we multiply by 3, we change the value of that expression. The 3 by 9 and the 9 by 3. Well, how about we just multiply this by an identity so we don't change it? Somebody said it, 3 over 3, right? If we did that, if we multiplied that by 3 over 3, what we'll have then is this is going to become what? 9 divided by 3x plus 3, which is equal to 9 over 4x plus 5. And what did we say a couple minutes ago? If the numerators are the same, then guess what? We just set the denominators equal and solve that. So we'd have 3x plus 3 equals 4x plus 5. And I hope that we could solve that in a couple steps in our head by this stage of the game. Anybody got it? Negative 2. X equals negative 2. Good. X equals negative 2. There you go. As far as checking goes, just a quick spot check. Make sure that whatever your answer is, that it doesn't turn the denominator into 0. If we plug in a negative 2 right in here, is that going to make the denominator 0? No. If we plug negative 2 in here, is that going to make the denominator 0? No. So that's it. What do you think? What I'd like to do is I'd like to look at this exact same problem and solve it in a different way, because you know what they say about the Eastwood Mall, don't you? There's more than one way there. That's right. So if we did what the book says to do, we would find the cross product, wouldn't we? We'd have to multiply that. Now, some people really are good at the distributive property, but forget to do it here. What's that cross product going to be? 12x plus 5, right? Oh, okay. Yeah, make sure you distribute, okay? And the other cross product is 9x plus 9. Good. So then we would get 3x is negative 6, and we get x is negative 2. Same thing, just a little bit different way of getting there. It's just like when you go to the hot dog shop. How do you go to the hot dog shop? Now you probably go to the hot dog shop, you take the bypass, right? And then you get off at where La Brea High School used to be, the West Market exit. Yeah. Or maybe you're coming home from the Eastwood Mall and you go down the strip, and then you go to the hot dog shop that way. Or maybe you go to Mountaineer and go to the hot dog shop in East Liverpool. It's not as good as the Warren one. The best one is the one in Girard, without a doubt. I think the Warren one was the first one, but the Girard one, their food's way better. So this alloy problem, I don't plan on giving you one like this. It'd be interesting to take a look at that. Maybe we will tomorrow, but I think we probably ought to look at least one more like this. So which one do we want to see? 1 or 2 or 3? 1? Okay. So let's... Well, 2 looks interesting. With 2, With 2, can we just like make one of those plus signs negative or one of those negative signs positive? It's not that simple. Multiply by -1 over -1. Well, that would change the sign of both things. So some people want to try to like make up their own rules as they go. You can't do that in math. There's certain things that you're allowed to do and certain things you're not allowed to do. So maybe we should look at 2 because it's kind of an interesting problem. So could we turn a 5 into a -4 easily? Probably not. Could we turn a -4 into a 5 easily? Probably not. So I'd probably go ahead and cross multiply here. Or instead of that, maybe, just maybe, maybe I could multiply this side by something over something and this side by something over something. And that would make my numerators the same. Or do you want to just cross multiply? Let's just cross multiply. Okay. So we're going to get 5x plus 15 equals -4x what? Plus 12. Good. So then we'll get 9x is -3. So x would be a fraction. Oh, dear goodness me. We get a fraction. That can't happen, can it? This is varsity math, son. And I know some of you say, I don't appreciate that comment. Maybe we should check that. Maybe we should check the calculator, see if it likes it. This is what I like, the copy paste and solve. -4 over x plus 3, thank you. And then the other one, the denominator is x minus 3. It's kind of cool. I don't even have to change that numerator in this one. There we go, -1/3. We got it. We're doing good. Fractions happen. Varsity math. Okay. Well, using LCDs, what they're kind of telling you here is all that stuff in 8.5. All that stuff in 8.5 where we had something like 3 over x plus 1 plus 5 over x. You're going to have to be able to handle that. You're going to have to be able to add those two terms together. Why? Because the way we solve proportions is to have a proportion. And when we have something like what we've got here, we don't have a proportion. What we've got going on here is 5 over x plus 7 over 4 equals -9 over x. Because of this right here, there's no proportion. We don't have a proportion. If we had a proportion, this would be really easy. Now, there are two terms in here that it makes more sense to combine than the other two. Who could tell me what terms it makes the most sense to put together? The ones that have the x's in the denominator, right? Do we kind of see that? So what I'm telling you is if we could get this term here to join forces with this term here, we might have something good going on, right? If we could somehow, some way, put those two together. So you want to subtract the 5 over x from both sides of the equation? That's a great idea. Subtract 5 over x from this side, subtract it from this side. So let's see what happens. 7/4 is still going to be 7/4. And we have -9 over x. We're subtracting from it -5 over x. Be careful. Be careful. Yeah, it is -14 over x, isn't it? Okay, so that's going to be -14 over x. And how do we solve proportions? Cross multiply. So we get 7x. A lot of people have a hard time multiplying bigger numbers by 4. Just double it twice. What's 14 doubled? 28. Double that. 56, and it's negative, right? Okay, so now we want x by itself, so we divide by 7, and x ends up equaling -8, and so our answer to this should be B. There it is. One like that is not so bad. They get more difficult. Any questions about that? Comments? Concerns? Short debates? Long debates? There is one thing that I think is worth noting. Equations can always be solved by graphing. What I mean by that is, if we were to look at that equation and we were to have taken whatever it is on this left side, this thing, and graph that, so 5 over x plus 7/4, 5 over x plus 7/4. If we graph that, and then also graph what's on the other side, that negative 9 over x, what we would be looking for here when we try to solve this equation is the point where they intersect. Good. And in fact, we'd be looking at the x value where they intersect. And if we find that, if we use our very special eyes, what's the x value where those two functions meet? Negative 8. What was our solution? Imagine that. What do you think? You mean we're going to have to graph those? Yeah, that's coming in the first part of the chapter, which we're doing after this back end of the chapter. Okay. All right. Example 4. I really like this one. 1 minus 8 over x minus 5 is equal to 3 over x. People crack me up. They tell really funny jokes sometimes. Or they do some of the silliest things. My wife, she has some funny things that she says, some of which I can't say. Repeat. I can't. I have a file stored on my phone that's called Melissa's Zingers. That's my wife's name, Melissa. But anyway, nevertheless, people crack me up. People try to just look at that one, and people go like this. They say, well, I could just cancel that out. I could cancel the 1 out. You can't do that. It's a 1. It's there. You can't just cancel it out. You can, however, do something with it. And again, just like the last one, there are 2 terms here that I think would be prudent to try to combine. What do we got? Combine the 3 over x with this term. Now that they need to have common denominators to be able to combine them, right? So what would I do to that 1? Multiply 1 by x over x. Good. X over x is the multiplicative identity. I'm multiplying 1 by itself. Okay. So I'm going to have x over x minus 8 over x minus 5 equals 3 over x. Now I can take these 2 terms here and combine them by addition or subtraction. So I guess I would have to subtract x over x from both sides, wouldn't I? Okay. So the negative 8 divided by x minus 5, that's going to be left over on the left. And what's going to end up on the right side of the equation then? It's kind of weird. Not 3x. 3 minus x all over x. How are we feeling? We see what happened there? I hope so. All right. So now we've got a proportion. What can we do to solve a proportion? Cross multiply. Sure. Do you notice one thing that I probably shouldn't skip over too much? Do you notice where this negative sign went to? This negative sign right there. Did you notice where I put that? I put it up with the 8. Okay, that's going to make this a little bit easier to work with than leaving it out front. So, all right, so my cross product, I'm going to get negative 8x equals, be careful here, you got to FOIL this. This other cross product, you got to FOIL. I've got x minus 5 times 3 minus x. That's going to give me 3x minus 15 minus x squared plus 5x, isn't it? So let's see what that's going to look like. Guess that's negative x squared. How many x's? plus 8x plus 8x, and then that's minus 15, right? So I really can't stand negative x squared, so guess what I'm going to do with all the x squareds? I'm going to put them on the left side of the equation. You all right with that? So I'm going to have x squared. Now I have minus 8x, and I'm going to be subtracting 8 more x. So what's that going to give me? Minus 16x, and then plus 15 equals 0. I gotta solve a quadratic equation. Maybe I should take the square root like that. Can I do that? Just take the square root of those first two terms and get x minus 4. Why do people do that stuff? That's the kind of stuff I see. That's what people try to do. We can't do that. Get that weak stuff out of here, young man, young lady. How are we going to solve it? Don't need the quadratic formula. What do we factor it? Sure. Teach me how to factor. Teach me how to factor. So what are our two solutions, we think? We think we get 15 and we think we get 1. That's what we think. Sometimes we think right, sometimes we think wrong. Remember what I said for a quick spot check. Plug into the equation and quickly try to see if your answer makes what happen? The denominator 0. 1's not going to make the denominator 0, and neither's 15. They're both probably legitimate answers. And they both work. How we doing? They don't get much more difficult than that. They really don't. This is kind of like some things that you saw on that quiz on Monday. And this is the last example we're going to look at today, and we'll end it with this. So 6 divided by x minus 3 is equal to 8x squared divided by something. Minus 4x divided by x plus 3. Why did I leave that denominator blank? Why didn't I fill that in? Because it factors. Thank you. It's a difference of 2 squares, and it factors into x plus 3 times x minus 3. Several different ways to approach this one. It would be really nice if those were the same, but they're not. Right? So, do what? Doesn't it all cancel in the middle? Well, what I'm thinking I might want to do is try to multiply this by something and this by something so that my denominators are all the same, and then I could just look at my numerators. Does that make sense? So I'm going to multiply by x plus 3 over x plus 3. I'm going to multiply. Oh no! Whoa! Let's try that one. Let's slow my roll. Let's try that one over here. Nope, I had it right the first time. Oops, I did. Sorry. I'm going to do that here, and x minus 3 over x minus 3 over here, right? All right. So that's going to make my denominators all the same, and the denominators are going to be irrelevant then, aren't they? So what's going to happen when I do this product? 6x plus 18, good. Now, over on the right side of the equation, I've got this 8x squared. I do need to do this product. What's that going to be? I'm going to be subtracting 4x squared and a minus 12, right? You see that? So what's 8x squared minus 4x squared? 4x squared, good. And what happens when I minus 12? That's going to be plus 12, right? That's going to be plus 12. So I'm going to put all my x squareds on the right, all the king's horses, all the king's men. I have 4x squared. I'm going to go ahead and bring my x's over. Minus 6x. 12 minus 18 is minus 6, and that equals 0. I'm really good at factoring. So what can I factor out of that expression? Oh man, the 12 should have an x on it. Who said that? Thank you. Good looking out. That saved the day. Saved the day. Oh, man. I am good at factoring. I'm not good at distributing. You guys are better at it than I am. 4x squared, and then what? Plus 6x minus 18. Minus 18, and that equals 0. So can I factor a 2 out of that? I can't factor a 2x. I can't factor a 2, though. So that's 2x squared plus 3x minus 9. I wonder if that's going to factor 2x, x, 3, 3, plus, minus. So I believe my answers are x equals 3 over 2, and I believe my other answer is that x equals negative 3. I think both of those work. What do you think? Extraneous solutions, the results of work well done that don't satisfy the original equation. Quick spot check. What do you check to see if your answer does what? Makes the denominator 0. Does one of those answers make the denominator 0? Which one? The x equals negative 3 makes the denominator 0, doesn't it? So that one's out. So our only answer to this is x equals 3 over 2. There you go. Hold on, there's more. A negative 3 is extraneous. What do we think of this? Whether you like it or not, it's here to stay. It's been real. It's been fun. Factoring. Got to know how to factor. Next week, expect a quiz on factoring. There's also going to be a quiz on Friday. It's multiple choice. It's Scantron. I think you're allowed to use a calculator on it, but that's going to be Friday. It'll go on the next 9 weeks. This coming Friday. But next week, do expect a quiz on factoring also. So that's it. It's been real. It's been fun. I hope everybody got something out of this. Those of you watching in YouTube land, thanks for watching. Have a great day.
Good.